Okay, in this video, we're going to just be looking at the start of the investigation that you're going to be starting today. All right, so we'll just skip those first few pages that you've got there and just try and get some sort of purpose. It's really different type of equations we're looking at, but I've just got it here. So just turn to this page and you can see that. It looks like a bit of gobbledygook, but really what you're looking at are the things that you've been studying, which are, indices. Okay, so here's one. So if we try and match these two up, you can see this value here. Oh, sorry guys, that might happen a bit today. But this value here, the 2, actually represents the B value. All right, and I know it seems weird that A value is actually 1, so there isn't really a number at the front. The D value is 0, and there's no C value at the top. Okay, so really what you've got is just y equals 2 to the x. So what you're really going to do is you're going to investigate all those letters, and we don't really know much about them, do we? So basically, to start off with, we are going to be looking at some key features in 3 different graphs, and what we're going to do is start to learn what those key features are and how to describe them. Okay, so what we've got here is 3 graphs underneath, and we're just speeding it up for you. One is what we call a quadratic, and you can see it's y equals x squared there. Below, it's the one that sort of looks like this. Okay, this is the one that our whole investigation focus on, which is like an indice or a power. And that one looks like this. Okay, and then the last one is something from semester 1. Oh, we used to love all those marbles, didn't we, for our investigation? Not. That's what we call a straight line. Okay, so they're the 3 types that we're going to be looking at. So if you have a look here, the one that really is of importance is the red one, right? Why we got the other graphs there? Well, it's just to help you understand the language, okay? So what's happened is they've graphed it, okay? They've subbed in some values, all right? And it looks like this. So what we're going to do on the next page is we've got a table to fill out to try and describe each of these graphs with some fancy words, okay? And really all you do for parts B, C, D, and E is do the same thing, all right? But instead of writing a table, we actually write a paragraph. All right, so the red one, I'll just write next to is y equals 2 to the x, okay? Our blue one, which is y equals x squared. I know they're not coloured on yours, but you can look at this anyway. And then our straight line, there it is y equals 2x. And we did a bit of that in semester 1, didn't we? All right, so let's go to the next page. And really, I am struggling for time here. So what I might do is just cheat. I actually did this with the other group this morning. And really, I've just already got the notes already. So we're just going back to that table there. Oh, maybe not. There were notes there. All right, it doesn't matter. All right, and we'll just write some notes about these. So when we saw the linear one, so write these down as we go along too. This is going to help you with your investigation. It's a bit jumpy today, isn't it? So you can always look back at the other graph. You can pause this at any time. So I'm just going to go through these really quick. But if you look at the shape of the linear graph, I guess I would pause now and then I'd have a go at trying to fill out all of these and then come back later. It's up to you. You can just copy these down. So when we think about the shape of the graph, it goes like this, right? So what can we say? I guess what we can say is it's increasing, okay? It's always going up, all right? Increasing, because we always go from left to right, okay? It's got a positive slope. That also means increasing as well. Really fancy one is, we do ask this specifically later anyway, I'll put it here. The slope is constant, okay? A straight line means the slope stays the same. You could grab any 2 points along there and it'll be the same. And when you look at the exponential graph, there's some weird things happening there, all right? I guess the first question will be what's happening with the slope? Actually, before we even do that, we'll check this one out. Is it increasing? Yep. It is going up, isn't it? So as you go to the right, it still keeps going up. So we can say it's increasing. All right. The slope is changing though. Slope is positive, but we say that the slope is changing. All right. And if you want to be fancy, you could say slope is, and I'll just put underneath, is increasing. Okay. It gets steeper, doesn't it? Look at it. you can sort of do slopes like lines. So can you see the slope? It's getting steeper and steeper, isn't it? All right, we'll talk about the last one. So when we look at this, what we call a quadratic, the shape of the graph, we could say it's a U shape. You can say whatever you like there, really. But I'd say as you're going from left to right, it's actually going down. All right, see that? It's decreasing and then increasing. So it's decreasing, then increasing. But also say the slope is always changing. All right. So we'll look at the next one. We don't have to do all of these today while I'm away, but they're not too bad. All right. The x and y intercepts, that's pretty obvious, right? So, if you're looking at y equals 2x, well, it's a terrible graph. All right. They go through the origin. So the x and y intercepts are the same. It just has one. Okay. They go through the origin. There it is. Okay. This guy, you do not have. So that's something you won't understand, but it actually has what we call a fence line. We'll talk about that in a minute. It doesn't actually go across this axis, okay? So the graph actually just has a y-intercept, and that's at 0, 1. And the quadratic, you can hear all my kids being sick there. And the quadratic is the same really as the linear. It's just got the same x and y-intercept, which is 0, 0. Now, this is the hard one. We'll just see how you go without me being there. But when you look at this thing here, it's a bit weird. But what it means is what happens as x gets big. Okay. And the other one is what happens when x gets small. All right. Okay, my graphs are a bit dodgy, but I hope you can see as your x values keep going along here, I hope you can see that the y values, if you plot all those points, right, just talking about this graph here, as the x values get big, so do the y values. So what we're going to do is say the y values get big too. All right. You have to use this mass notation in your assignment too, okay? I might have to wait till next lesson to show you. Now let's have a look this way. So as x gets small, so this is going this way, right? So I hope you can see what the y values are doing. They seem to be becoming more negative too, right? I think the y values are going to get small as well, all right? Now the exponential, or the indice or the power graph, there's all these names for them. I'll just redraw it again. As x gets big, let's see if you can work out what's happening here. So as x gets really big, I hope you can see y's are getting really big. So we just say really big. This is where it's different. As x gets closer to minus infinity, or very small, can you see this way? So this is like a fence line. So it's actually never going to hit it. But what's actually happening is it's going to get closer and closer to it. I hope you can see the y value there. Do you know what the y value there is? It's 0. Okay, so y is going to approach 0. You can be fancy about it. You can say it's from above. All right, the last graph, we can see it up here. As x gets big, okay, there it is. As x gets big, it's a bit like the exponential one. Y is going to get big as well. This is where it's a bit different though. As x gets very small, so you see this? So as x, look what y is doing. It's actually going up. So as x gets really small, y gets really big. All right. Now I've already done this one, the slopes of the graph. So that was sort of like, constant. So maybe, I've already written it having a constant. This one is increasing. They were both positives, weren't they? And this one was, our quadratic was decreasing, then increasing. All right, increasing. This one was always changing. That one was always changing. So I've already said that. Yeah, so there's something about asymptotes, horizontal, vertical asymptotes. There are none, okay, in either of these graphs, but this one here does have one, and you've never seen one before. So all the graphs you're going to look at in this investigation are this form. So it's like a fence. Okay, can you see there's a fence right here? I'm going to draw it in green. So I guess you've never seen this before. You just need to envisage that you can't actually go over that line. You can't even touch it. So remember when you were doing lines, that vertical were x equals lines, okay, x equals, but when we do these, they're at y equals. So we can say that fence line is y equals 0, okay, it's on the axes. Again, just try and do it today, see how you go. All right, really, each part of this investigation, you don't have to do a table, but you have to try and use all the words we've got here now, and more, right? Why did that disappear? All right. So if you look on the next one, try and add more if you can here, okay? So if you can think of anything else that's interesting, that will help your investigation. I'm just giving you a general outline. All right. So that's really part A done. There you go. So what we're going to do in part B is, if you look at that general form of the graph, it was A times B to the X minus C plus D. Oh my goodness, it's a lot. We're just ignoring A, D, and C. All we're actually going to do in this part is actually change the B value so it's like the base. Do you see that? So we start with 2, then we're going to make it 7, then we're going to make it 10, and so forth. Sorry guys, it's a bit twitchy today. Where the heck am I? Right. So we're going to have to learn a method. I might show you an example in a sec, but what you need to do is we're going to use Desmos. You're going to graph all of these, okay? And then once you've learned how to graph them, we then will stick them in here. So you'll have an assignment. And then all of this, do you know what that is? That's the table that we just did, okay? We just realized we're just focusing on these graphs, okay? So we're not actually worrying about the linear one, which was in the first column, or the quadratic. I was just trying to help you understand what these key features are, all right? So we're just focusing on these. All right, you're going to need to use Desmos. So get your laptop out, okay, which you should have anyway. We're going to go to Desmos, so I'm going to do that as well. So just go to desmos.com. And can you all do this before you even start? You sign up. Do you see that? If you haven't used it before, do that. Or log in if you've done. Signing up, you can just use Google, which is just your school account. So just log in. I'm going to do the same as you guys. What is it doing? Just use Google. That way, any graph you do, you can save, right? And you can see here, I can save a copy. I can name it. I'm going to call this part B, right? Now, I forgot what the graphs were, but I'll just put one in here anyway. It's a bit of a pain using it like this without a typewriter, so just bear with me, guys. I'll just hide that. That might help me. Y equals. So you can just use the up arrow, which is Shift 6 on most calculators, but you write 2. I'm going to use a different button because I'm using this. You could just press 2, Shift 6, I think, and then X, and there you go. All right. Now, you can actually move them around. Okay, see that? You can actually change the color. Watch this. If you hold down left click on that guy, you can make it green, you can make it orange, you can make it dashed, right? You can change the size of the font, so I can make it 10. Whoa, that's crazy, isn't it? So I know some of you guys love doing that sort of stuff, so you can do whatever you like there, all right? And then you put the other graphs. Now, I can't remember what they were, but it doesn't matter what you do. I'm going to put a couple that will really help you understand. So I'm changing that base, right? So I'm going to do this one, 4 to the x, and then I'm going to write y equals 6 to the x. All right, what do we got here? All right, not 6 to the 6, 6 to the x. There we go. All right, so you can see these graphs, and hopefully you guys can see what's happening here. Do you see that? As I make the base bigger, right? So we're going to go back to our table. What you do is you start talking about all the things we just did in the other table. So what did we start with? Slope, didn't we? Or the shape of the graph. So all the shapes of these graphs are increasing, right? All of them have the same, see the cursor, have the same y-intercept, but they're all changing in slope. But can you see the dash one, which was 2 the x? Its slope isn't changing as fast as the green one. or the purple one. So we can start to be smart about this and go, oh, look, as we make that B value bigger, it seems to actually make them become more steeper, more quicker. All right. So that's really what you've got to start talking about in that part. Now, it's not as easy as that. Watch this. If you do the ones that are less than 1, I forgot what do we got? 0.8 to the x. Look at that. It's different. Right, you know. But look, it still has the same y-intercept. It's still, look, still got the same asymptote by the looks of it. It's just on the other side, you know. So you're trying to use words, maybe some words like reflection or, you know, it's decreasing. All right. And so that's what you're doing here. So remember, you save it as well. You know, I've called mine part B, save a copy, because what might happen is later we might want to actually go back and change it. So you can actually just print screen these and then dump them in the assignment. Okay. Now you all have an assignment set to you, so make sure you're using it. So I hope that sort of makes sense how to get started. I know I'm not hit there, but you know, it just says describe how the B value. So remember the B value is the base, right? In this case, it was 2, 7, 10. So how does it change the shape, right? X and Y intercepts. Horizontal asymptote, looks like it was the same. Endpoint behaviors, well, that's as X gets big, right? Or X gets small. And anything else, all right? So that I hope you guys understand the whole idea of this table is to help you give you a vocab and idea of how to answer these questions here. All right. Transformations. Well, it's on the front page. I haven't mentioned the investigation, but that might be something that you might want to look at on your own, or we just wait till next lesson. So really, what would be good today is if you get all your graphs done, obviously write down all those things on the previous page, get all your graphs done, get them nicely shown, and then have a crack at writing this. In the final investigation, we want it as a paragraph, not as a table, okay? So have a go at writing that up, okay, and make sure you run on your classroom assignment. So homework's to finish part B, you know, and there's part C, D, they're all the same. All right, that's it for the video. So hopefully that will help you. I'll let you guys get on with it now. Thanks.